So a popular topic of question for exams in sport or PE is spirometry, or your ability to read spirometer traces. Now in this example here, they're looking for a multiple choice answer, which is quite a simple way to get 1 mark, and they could give you it in 2 different ways: the definition, and then you have to give them the key term back, or they give you the key term and you have to define it for them. Another way is that they actually give you a spirometer graph or a spirometer trace, and you have to label or annotate or explain what's going on at different stages of that spirometer reading. Now for this one, before we go into the answer, we first take a look at what the spirometry graph entails and what it can look like. So we'll nip into the whiteboard, and if I quickly draw a very basic graph where on the y-axis, x-axis is obviously time, and on the bottom, the y-axis is the fill of the lungs. So up to 100% fill, down to 0% fill, sorry I should say. And this is measured in litres or millilitres typically, but you don't really need to concern yourself with that at this point in time. So to start with, we see a bog standard breath in and breath out, and anything that bounces between these 2 levels is known as our tidal volume, our TV. So the volume of air that we breathe in and the volume of air that we breathe out at rest. Now if you wanted to work that out, then it's just the differences in the wave height. So you would measure where the graph gets to on the inhalation, measure where the graph gets to on the exhalation, and the difference between the peak and the trough of the wave is the tidal volume, the amount of air that we breathe in or out per breath. Now if we were to carry this black line on, and change it to orange now, and we continue to inspire, continue to inhale, this is the volume of air that we have in reserves in inspiration. This is what we could additionally breathe in if we needed additional air to enter our body for either excess oxygen or to get rid of more CO2 in the next breath. So this additional volume of air that we could breathe in following inspiration is known as our IRV, the volume of air that we can breathe in following a normal inhalation. The same can then be said on the opposite. If I just draw this line all the way back down, anything that goes beyond a normal exhalation, I'll put it in red here, is our expiratory reserve volumes. The volume of air that we have available to exhale on top of a regular breath out. So if we do have high amounts of CO2 accumulating, we could exhale an additional volume of air following the normal exhalation that we've just experienced. By doing that, we also free up more space for the next breath in. So if we add on to this graph now, a maximum inhalation following a maximal exhalation, what we actually have here is something known as our vital capacity. It's our expiratory reserve volume plus the tidal volume plus the inspiratory reserve volume gives us the vital capacity. It's the space inside of our lungs that we actually have access to, that we can completely empty or completely fill in any given breath. Now there will always be a section of our lungs that we can't empty. Now there's always going to be a volume of air that resides inside of our lungs because we haven't got the mechanics, we haven't got the mechanism, we haven't got the structures that can actually compress the lungs to the extent to empty it 100%. There's always going to be some left inside of the lungs, and that's known as our RV, or our residual volume. It's the volume of air that's left inside of our lungs following a maximum exhalation. Now this could be from the base of our tidal volume, it could be from the peak of our tidal volume, it could be following a maximum inhalation, but following a maximum exhalation down to the point that no more air can be forced out, whatever is left inside of our lungs is known as our residual volume. So then the final thing that we do have is the residual volume plus our vital capacity gives us our TLC, our total lung capacity. This is the full amount, the full litres of air that we can fit inside of our lungs following a maximum inhalation. So we've got our maximum breath in plus what was already in there to start with gives us our total lung capacity. So if we jump back to the question now, which one of these lung volumes is defined as the volume of air left in the lungs after maximal expiration? Well, following maximal exhalation, what volume of air is left inside? It's our RV. So the answer for this question would be C, our residual volume. But as you can probably work out, they could have changed the definition that they gave you to any one of those definitions associated with the spirometry trace. So make sure that you know all of them for your exam, so that whenever a definition comes up, you can give the key term. And also, if they give you the key term, can you define it in relation to what's going on? Inhalation, exhalation, residual volume, etc. So that's that. Hope you found it useful, and I'll see you again in the next video.